Today, students, let me present to you our performance task for general mathematics this first term, school year 2020-2021. Let's first recall what is graphs. G stands for goal, R stands for role, A stands for audience, S stands for situation, P stands for product, and S stands for standards. Let's see your graphs. As a member of the community, it is your responsibility to keep track of how much waste you are producing. Plastics are one of the most used material that can either be recycled or turned into waste. Unfortunately, because of the practicality of using plastics, people often neglect its long-term cost to our environment. Remember, plastics do not biodegrade easily. Now, this is a situation which is the S, first S in our graphs. And I hope that as the Salian students, you understand the issue that is being presented to you in this presentation. Our performance task is focusing on environmental science, and we are doing this because primarily you are STEM students. You are expected to be aware of the current environmental issues that are present in our society. The question is, how big is this problem? Let us start by looking at the smallest unit of the community, your family. As a learning member of your household, observe your family's plastic consumption and disposal habits. With a team of three, create a mathematical model that computes the amount of plastic that your families are consuming, which ends up as waste. Predict the consumption and disposal rate of plastics as waste over time, and you may also consider the disposal rate of plastics as recyclable. So in this paragraph, you're being asked to look around your households and observe how your family is consuming plastics. How are they disposing plastic? Now, it is important that we identify the product that you must produce. According to the graphs in this paragraph, your product is a mathematical model. The mathematical model should be able to compute amount of plastic consumption, specifically plastics that are turning into waste. And you need to predict how much plastics you will be producing in the near future. Now let's move forward. What should your model look like? What are the characteristics of your model? So your model should be developed based on your observations within your households and the households of your classmates nearest to your area or who are living in a community like yours. The idea of this group work is for you to look for group mates who probably has the same community as yours. It's suggested, but it's not forced. At the end of the day, it's also good to look at perspectives of different communities so your model can be applied to a bigger situation. You will be demonstrating how much your model works by applying it to each of your team's households. So this is the testing part of your model, and the demonstration will be through a recorded video presentation. Once you already have the model, you will be recording yourself together with your group mates and present this model as applied to your own situations. And they will be rated according to these four criteria. First is accuracy, second is thoroughness, third is generalizability, and fourth is quality of presentation. Now, since we are talking about the product, which is the mathematical model, the big question that we have right now is, what is a mathematical model? How do we create one? So if you're not familiar with a mathematical model, let me present it to you. A mathematical model is a representation. It represents a system or a scenario to gain information, which can either be qualitative or quantitative, about real world issues. Using this model, we can predict future behavior. We're using this model to understand issues that are affecting the society at large, and we use mathematics to explain such problems. Now, I have here an example. What you're seeing right now is an example of a mathematical model. Now, this mathematical model is composed of different variables. And as you can see, this might look overwhelming right now because you're senior high school students on your first term in grade 11. Variables are not defined yet. Now, that's your task. As students, when you create your own model, just like this one, you need to name your own variables. You need to represent a situation or a factor into a variable that could further define your model. Remember, one of the skills we strengthened all throughout the discussion of general mathematics is representing situations into function or equations. And this is where we use that idea and the rest of the skills or competencies you acquired during this term. We are saying that that's the skill that you must apply here. We should understand that the word problems presented to you in your class is different from a mathematical model problem. And this requires higher order of thinking. Now, how do they differ? So I have here an example of a real world math word problem. And then I'll present later an example of a real world mathematical model problem. Let's read. The population of a community is 20,000 and 35% of its citizens recycle their plastic water bottles. If each person uses 9 water bottles per week, how many bottles are recycled each week? Now, this is our real world math model problem. How much plastic is recycled in the community? These are two different problems. If you will notice, the first problem is kind of more specific and it has more information because the number of people in the community is already given and the amount or the percentage of citizens who are recycling water bottles is already given, then that means you can represent it into a function and then evaluate the variable that we have here using the value that was given. According to the problem, there are 9 people who use water bottles per week. Comparing it to the other problem, how much plastic is recycled in the community, we can say that the second one lacks information unless you Google it, but specific to your community, specific to the type of household you are living, I guess not. I guess it's not yet answered. That's the very reason why we're doing this mathematical modeling. We are supposed to create our own function rule that we can use so we can answer the question earlier. The question, how much plastics are being consumed in your households and how much are consumed yet turned into waste and not recycled? Now, what are mathematical modeling problems? Mathematical modeling problems are not straightforward. When you encounter one, you will think, I don't have enough information to answer this question. That's because the key point of a mathematical model problem is that we usually don't have enough information about these issues. That's why it remains as a problem because we still have a lot to answer about this issue. Mathematical modeling problems are also open-ended. Since it's open-ended, it allows us to use creativity and our skills in mathematics to complete the information that we needed to solve the problem. It gives us an opportunity to analyze the situation using the lens of mathematics and then propose a solution about an issue using the model that we created. So, what must be done? What steps should we follow? What are the things that we should remember when we're creating a mathematical model? Well, in order for us to answer the modeling problem, we need to do researches. That's number one, research. Number two, we need to make our own assumptions. There are times when data are not available, and when they are not available, we create our own reasonable assumptions. And number three, strategize in answering the question because we need to identify the variables, we need to evaluate our model. So we need to create a strategy of our own so we can make sure that our model is a quality model. Now, please understand that we may have the same modeling problem, but because we have our own set of experiences, we have our own schema, then we can approach a similar problem with different perspectives. One solution can be different from another solution. One's idea can be different from another's idea. Now, this is our mathematical modeling process. We start with the real world problem. This real world problem is often given by your professor or an organization you are in. But this time, since we're in a school setting, it will be given by us, your teacher. This real world problem needs to be processed using this cycle. As you can see, this is cyclic. That means you can start from here, defining the problem, go to making assumptions, proceed to defining variables, then go back again to defining the problems. So how does it work? We need to define our problem. We need to turn the generic idea of the problem into something specific, because the problem that will be given to you in a mathematical model is something that can be applied or something that is yet to be specified. You need to define your limitations. You need to identify your parameters. Uh, when we talk about this term, what do we mean? When we talk about another term, what do we mean? Mathematical modeling problems present to you terms that can be perceived differently by different individuals. So you need to decide as a group, how do you define this term? After that, you make assumptions. Just like what I mentioned earlier, you need to set your parameters, and setting parameters to make assumption about a certain condition on the certain specific issue. There are times that the data is not available because it's impractical to gather the data from a larger population. Likewise, data are really not available and it's very difficult to get one. So you need to create assumptions, but remember that the assumption must still be based on related researches and they must be reasonable. You cannot create assumptions that are too ideal, assumptions that may not be true. And then after you create your assumptions, you start defining what your variables are. What are the variables that affect or that are factors to the issue presented? And these variables might either be independent or dependent variables. And when we talk about variables, we can also consider the counterpart, which are constants. Are there constant values that must be applied in our formula, in our mathematical model? And when you're done defining your variables, you don't just proceed to getting solution. There are times when upon defining your variables or upon making your assumptions, you tend to go back to the redefining your problem because an idea pops up into your head that we should redefine our problem this way because it's clearer to us right now that we have our variables. So you go back to your definition of the problem. And you can always go back to the other two processes, making assumptions and defining variables. Now, this is only going to be successful if you will be basing your ideas from research and your own experiences. And of course, you will be brainstorming. It's difficult to do it alone. That's why you need your friends or your group mates to work with you. Following the process is getting a solution. Now, notice that I used the article a instead of the article the because we are in the assumption that a solution to issue real life problem is not absolute. That one's idea of a solution may be different from another, but still work. And then next is analysis and model assessment. Not because you're able to create a model, you'll stop there. You need to, again, step back. Try to look at the picture. How is our model? Is it good enough? Is it applicable to different scenarios? Can we use it to this community? So we ask ourselves reflective questions about the model. And when we feel like the model is not yet good enough, we go back to our process here. We redefine the problem, we review our assumptions, our variables, and once we are sure that the model works, then that's the time we go to the last step, that is applying the model to report results. Now, these are the task guidelines. First, you need to have groups. The group should have a minimum of three and a maximum of five. A link to the grouping sheet will be shared to you. Remember that this whole performance task is composed of five tasks, four worksheets, and one final output. The four worksheets are scaffolds of your final output, which means that each individual task will help you create the final one. Deadline, since we are following scaffolds, then each worksheet has its own reasonable deadline. The whole performance task will run through a month, starting today, September 4, up until September 3. So you can use the whole period to Perform the process or the flow of mathematical modeling presented to you earlier. And lastly, standards. Since we have four different worksheets and one final output, then we're going to be presenting to you different set of rubrics for the worksheets and output itself. Now, these are the scaffolds. Worksheet number one is about defining the problem. What will be asked from you is a mind map. Worksheet number two is making assumptions. What will be asked of you is a preliminary research and list of assumptions that you have for the problem presented earlier. Worksheet number three is defining variables. You need to know which are your input factors and which are your output factors. And because you're already defining your variables, then you can already have your initial model. And because you already have your initial model from worksheet 3, it's time for you to evaluate that model in worksheet number 4. Now, final output again, it is a video recorded solution presentation. That means you need to work as a group, although you're far apart right now, to create a video. It could be of any medium. It will further be discussed to you once you are or once we're already at that part of the mathematical modeling process. And just remember that the video presentation is a conclusion of all the worksheets. That means the data that you have created or the information that you've provided from the first four worksheets should be present in your final output.